Namaste. Hope you are doing well. Today we will solve the 23rd problem of ISI MSTAT 2024. And yes, it seems to be a descriptive statistics problem. You are given notation of the mean and the variance for a given data set of two elements, all of them belonging to the interval -1 to 1. And you are further given S square max as the maximum value that this variance S squared can take. And you have to identify amongst the given four statements which one is the false. So let's get started. Now, based on the nature of the options, the four options given to us, we see this S square equals to max, this condition coming in. So we would want to connect the dots on the situation where the variance S square is maximized. What could be that situation? And given the nature of the data, which is an even number of data elements on a bounded region with two extreme points, obviously, in order to maximize the variation, in order to get S square max, we would want to have our data in such a way that the data is at an is as extremely separated as possible. And the way to go about it is to have the n elements out of the 2n as one extreme and the other n elements in another extreme. Think about it. This is, in this setup, the most extreme case possible. And this was why this number of elements was 2n. Now, the second thing to connect is what would be a meaningful situation when S square is minimized? Because there is an option which talks about the range of values that S square takes. So in order to have an idea about that, we would also need to know the least value that S square can take. And variance is minimized. Basically, variation is minimized when everything is the same. So if all of these elements are the same, then the variance would become 0. And we could have a situation like xi being 0 for all I, all the elements being 0. Then in that case, the variance would become 0. Now let's eliminate some options that we have connected some dots. Now, we know that all of these values are bounded like this. So if we take the sum of all of them, even that would be bounded by -2n and 2n. And then you see where this is going. If you take the average, which is the mean, you get something which is between -1 and 1. Pretty standard. So this is correct. And hence this is wrong because this is correct. So this cannot be the answer for the question. Now, we already discussed the situation where S square is going to be maximized. So if we plug that in, now half of the data is -1, half of the data is +1. If you take the mean, that becomes 0. And when you plug this formula in that context, you get S square to be 1 exactly. And we get the answer that when the mean is 0, then the corresponding S square is maximum. That thing is false. Because we saw that this is true. Because we found the value of S square max, which is 1, we see that this is true. And when indeed S square is maximum, the mean is 0. So this is true. So what remains is this, that mean being 0, but S square would be S square max. This is false. And this is simply because we discussed this situation where every element is 0. Then in that case, the mean is also 0. But still S square is not S square max. It's in fact S square min. So that's why this is false. And some base to build your base is two situations may mean the same but still vary. And the context is that the situation where S square was the max value, S square max, even in that case mean was 0. And when S square was minimum, even in that case the mean was 0. But we see that the variation in these two cases was different. And if this was helpful, then the request is always try to not speak different than what you mean. Honesty in dealings really simplifies things from business deals to academic conversations. Take care. Hare Krishna.